Hello everyone, today let's solve the problem number 191, number of 1 bits, right? So this basically, let's go through the question. So let's see what the question states here. Given a positive integer n, we have been given a positive integer n here. See, we have to write a function that returns the number of set bits and its binary representation, right? Also known as the Hamming weight, right? So this is fine, I believe. Given a positive integer n, we have to write a function that returns the number of set bits and its binary representation, also known as the Hamming weight. This is fine. So the output that we need to get here is 3, right? For the n equals 11, the output that we need to get here is 11. The input binary string 1011, see here, when we convert this one to the binary, we have 3 ones, right? So we have to count the number of ones in the binary, and finally we have to return the number of ones here. So we have 3. The input binary string 1011 has total of 3 set bits, so that one will be returning this one as the output. Second example, same here. See here, 128. So when we convert this one to the binary, we have 1 followed by these many zeros. So only 1 of 1 we have, right? So we we have to return 1 in this case. Same goes with the third example as well. We have some number, large number they have given here, 2147483645. When we convert this one to the binary, we have this one. So the total number of ones is 30 here. You can count here. The total number of ones we have here is 30, right? So the output that we need to return here is 30. This is fine. So this is it for the question, right? So let's do one thing for this particular problem. Instead of discussing the approach first, so let me write the code. Along with the code itself, I'll write the I'll explain the approach basically, right? So this is fine. First, let's do one thing. Let's initialize the count to 0. We need the result variable, right? So we need to count the number of ones basically. So here in this case, the result variable is count. And let me go with the while loop. So while n not equal to 0, while n is not equal to 0 basically, right? So then we have to turn off the rightmost set bit, right? So we can just make use of this one, n bitwise AND operator we are making use of here. So this will be n minus 1. We are just turning off the rightmost set bit here, right? So this is fine. Then we'll just increment the count if you find 1. If you find 1, right? So finally what we'll do, we will return the count, meaning so we have to return the count. So let me format the code once here. So let me tell you what we have done here. So this part n ampersand equals this one, bitwise AND operator we have made use of here, right? So this one n ampersand n minus 1, this removes the rightmost set bit of the n here, right? So first thing is we are going with a bit manipulation to solve this particular problem, right? So we are going with a bit manipulation to solve this particular problem. Let me write this one if you don't understand, right? So if we don't understand, I don't understand most of the time, right? If someone doesn't explain. So we are going with a bit manipulation. This is fine. Now each iteration increments the count. Each iteration, what it does, it increments the count here. See this one, right? If you find the one basically, loop continues until n becomes 0. Loop, so this one loop continues until n becomes 0, right? So while n not equal to 0, then only we have to move into this part, right? So while n is equivalent to the 0, or while n not equal to the 0, so we are going with n bitwise and n minus 1, and count we are incrementing, count plus plus, right? So we are just turning off the rightmost set bit here. Finally, what we are doing, we are just returning the count. So this one loop continues until n becomes 0. The final one, the time complexity would lead to. So this is it for the code and the approach. It's very simple, right? So the time complexity here would lead to because of number of set bits, right? So number of set bits that we have, the time complexity would be based on that basically, right? So the time complexity would be because number of set bits, and it is very efficient for the sparse numbers basically. So this is it for the code, right? So I hope the approach part, complexity part, and the code is completely clear, man. Let me hit the run button. Hope this works for all the test cases. Let's see. So yeah, you can clearly see here sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed, means the code works absolutely correct here, right? So whatever the code that we have written works absolutely correct for all the test cases. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.